Now this is a familiar scene. The sun's heat causes water from plants, lakes, and oceans to turn from a liquid to a vapor. High in the atmosphere, the water vapor then cools down and condenses from a gas back into a liquid. The liquid water then falls back to the surface in the form of rain, snow, ice, or hail. Water runs off into streams, lakes, and oceans, or is stored in the ground or in snowpack. This is the water cycle, and it describes how our most vital resource moves through the whole Earth system. But like most things in our world, when we look at the tiny parts that make up the whole, we can learn a lot more about the phenomena. Take the shape of a single raindrop. Small droplets of water in the atmosphere are spherical in shape due to the surface tension or skin of the water molecules. As these droplets grow, they become heavier and start to fall through the air. As they fall, the raindrop collides with other drops and continues to get bigger. These larger raindrops fall through the air faster. The wind resistance on the underside of the drop causes the bottom of the drop to flatten, resulting in a drop looking like a hamburger bun. As the drop continues to fall and grow, at some point it becomes too large for the surface tension to hold it together, so the raindrop breaks apart into smaller spherical drops. Investigating the processes we can't see with the naked eye is nothing new. Science and technology drive each other forward and often lead to insights and discoveries along the way. With the invention of high-speed photography, we finally saw the most basic elements of our watery planet in action. Understanding how a tiny raindrop falls through the atmosphere does more than debunk the myth that a raindrop falls like a teardrop. It actually makes a difference when it comes to measuring precipitation. In particular, for ground radars. Ground radars look at the sides of the raindrops and then estimate the vertical and horizontal size. A heavier, flatter drop allows radars to identify heavier precipitation. In fact, the two radars on board the GPM satellite can also measure drop sizes from space, and so a more accurate look at raindrops gives us a more accurate look at how global rainfall is shaping up.